Good evening. Today we want to handle integration by parts. So we have a problem here. E to power x cos x dx. We want to integrate by parts. So we have two differentiable functions, ex and cos x. And our formula states that u, the integral of u dv, is equals to uv minus the integral of v du. We have our two functions, so let u be e of x. When we differentiate to get du, we will have e power x dx. Our dv automatically becomes cos x dx. For us to get v, we have to integrate cos x. When you integrate cos x, you'll get sin x. Substituting in our formula, we will have the integral of ex cos x dx is equals to uv. We have our value for u, we have our value for v. U is e power x sin x minus the integral of v du. Our v is sin x and our du is e power x dx. So that's our equation 1. You can see that in this equation we will have to integrate again by parts because we have sin x ex, which has to, we have to do it again. So we are going to have e power x, we have e power x, e power x will again become our u. So our du is e power x dx. If you differentiate e to power x, you'll still get e to power x dx, and this time our dv becomes sin x dx. If you integrate sin x dx, you'll get negative cos x. We repeat the same process. We will have uv minus v du, and this gives us uv is minus e power x cos x minus v du. As it gets us a plus integral of v du. Our v is cos x, du is e power x dx. We have to substitute the value we have here into our equation 1 so that we can finish solving it. We'll write everything. So we have e to power x cos x dx is equals to e power x sin x minus, so we were integrating sin x ex dx. We had this value here which we're going to call equation 2. We substitute 2 back, so we will put a bracket, then we will have minus ex cos x plus the integral of cos x e to power x dx. We're going to expand the brackets and see what we get. We will have e power x, and now we have minus minus, it gives us plus e power x cos x minus the integral of cos x e power x dx. If you observe carefully, you realize that our last value here, where we have underlined cos x e power x, that integral is the same as what we have on our left hand side. So we are going to collect the like terms. That means this one is a negative. We will add it to the left and get 2 integral of e power x cos x dx is equals to e power x sin x plus ex cos x. But now we are only interested with the value, so we are going to divide by 2 on both sides so that we can get the integral And now we see that the integral of ex cos x dx is equal to, we can simply put everything over 2, or we can write a half ex sin x plus ex cos x, and that's our value. Thank you.